Hey guys, I hope everyone is doing good and moving onwards. We'll be studying for technical, general or technical specific subjects, or you want to call topics. And I would suggest that if you're studying for all these topics, you would be studying for technical general, because for technical specific, I would recommend you study the POH, and that's going to make you through the exam, because DGCA is looking for the specific subject, specific aircraft. That's why it's known as technical specific. For example, if you're giving for C172, so DGCA is going to ask the majority of the questions from the Cessna POH or the Cherokee POH or Tecnam POH. So it depends. But yeah, in today's topic, what we'll be starting with will be aerodynamics. Now, if you think about normal basic term aerodynamic, so you know that okay, so you're talking about something relative to the air. So the definition of being the basic aerodynamics is the study of movement, air movement around the object, revolved around the understanding of four forces, that is lift, weight, thrust, and drag, which determine the object's motion through the air. Now in this case, our object is what? The aircraft. Now this is something that is going to help you out throughout the initial phase of your training to understanding the function of the aircraft. So what it's stating basically is that this is your CG, right? The black thing. Now what are the four forces that is acting on this? One is lift, drag, weight, thrust. Lift is something that it pulls the plane up. Drag is what? Holds the plane back. We're talking about the plane, not something else, if you're wondering. So what is weight? Which makes the plane heavy and sink. And what is thrust? Basically what pulls or pushes the plane forward, depending on from which perspective are you looking at it. It's not that hard. It's basically a ball. If you throw it up, it's going to accelerate, going to reach a position, start changing the direction, going downwards. This force is what? Gravity. Now in the same section, this is how plane is going up. The thing that is going to bring it down is weight. Same. This is going forward, acceleration. Now bringing it back, drag. So if you want to move forward, you need to have more thrust than drag. Otherwise the plane will keep on slowing down, and no matter how much thrust you're putting, it's not going to give the optimum output. Same goes for lift and weight, and hence that is why the CG is very important inside. Once you start going for the POH, or when you start your training, you will understand why CG is so important for the aircraft. Aerodynamics, basically what we are studying is how the air works around the aircraft aerofoil. Now a lot of you might or might not know what is aerofoil. Aerofoil is basically in this section we will be studying about the wing, and for wing or the structure of the aircraft we call it as aerofoil. Now to understand what is aerodynamics in detail, we will be looking at the key components of aerodynamics. The first component is going to be what? Angle of attack. Now if you look at the drawing, you will see there are multiple lines going from starting to the ending, and there's arrows and all whatnot. Now to understand in basic layman's language, let's consider this is a normal plane. Right. Now keeping the same wing area on this drawing. Now to understand this basic understanding, we need to know, or at least remember, Newton's third law. Now this is your air. The air is going to come, it's going to hit the aircraft from underneath, and it's going to create a pressure point on all of the aerofoil of the aircraft in this wing section. Now if this let's consider this as action of the air. Now what is going to be the reaction if this is the action? Obviously it's going to be like this. So every action has an equal and opposite reaction. So if you are hitting the wing with the air from downward section of the wing, or you want to call it from anywhere, in any case it's going to create a pressure downwards, which is going to make the aircraft to lift up. Now this area, this one, where it all starts, it can be this, it can be this, it can be this, or it might be this. It depends on situation to situation. Now this section, or this is the starting area where the air is hitting and it's creating a differential pressure, that is known as angle of attack. Because if you keep this normal plane at this section, so the point is this. If this is the normal plane, the point is this. If this is the normal plane, the point is this. So wherever the normal plane is, depending on the aircraft wing structure, dihedral or whatever you want to call it, the angle of attack is going to be there. Now the aerofoil that we're talking about, or the wing that we're talking about, has two sections. One is the trailing edge, leading edge. It's easier to remember because leading is what? In front. Trailing, it's going to be the opposite. Now if you'll see, you'll have confusion of what is chord line and what is cable line. Chord line is nothing but basically the angle from the starting of angle attack to the ending of the wing. And chord line is basically a structure inside of the wing. Let's suppose the wing end goes from leading edge to the trailing edge. It's inside the aircraft, you cannot see from the outside. Now if you have understood the angle of attack, whatever I have explained you above is the same. If you see in this one, you see this is where all the magic happens, or you can say this is where the difference starts. The air comes along, it gets differentiated, one molecule goes up, one molecule goes down, and it'll keep on traveling, and similarly they'll reach a point in the end where they're meeting, and you will see how it's mixing up, right? Now to understand the pressure, either you can understand it by high pressure or low pressure, or you can understand it by high velocity or low velocity. This is equivalently relevant to your angle of attack. Now if you go further in this section, then the other thing that is talked about was drag. Lift is what? Basic lift, what is generating. Now wherever the lift is going to be generated, it is always going to create some drag. That depends which kind of drag. It can be induced drag, or parasitic drag, foam drag, skin friction, or interference. Now to understand what kind of drag, you need to understand what are the types of drag. Now what is parasitic drag? Parasitic drag is basically whenever something touches the airframe, it generates parasitic drag. So if you have aerofoil and it's touching air molecules are everywhere, downwards, above, around the wing, around the aircraft, so it is always going to create parasitic drag. That is the basic definition, that wherever something touches the airframe, in this case it's what, air molecules, it's going to create parasitic drag. Then we come to foam drag. Foam drag is basically due to the shape of the airframe. Now to understand, you will see that here airframe is just one thing only. How can it be different? See, there are so many different types of airframe. Now what if you are flying WH supersonic? Although you are not going to fly this, but still. So as you see, we have different types of aerofoil. So aerofoil decides what kind of foam drag you're going to get. Similarly, if you go to skin friction is nothing but the drag generated from the air molecule that comes within contact of the outer skin of the airframe, which is going to be the air molecule that is close by to the airframe of the aircraft. This is what going to create a skin friction drag. And same goes with the interference. Now, interference is what? Drag caused by interjunction of the airframe. So let's suppose you were landing and you put on your flaps. Now what is the flap going to do? It's going to create a more steeper, we're going to call more area above the aircraft, so that the wing have more space to deflect the air that is coming along. So this area, in this, the joints, these joints are going to create interference drag. It's very basic. If you will go through with your basic definition that is given in the book, you'll understand it's not that big of a thing. Now the other key factor that is very important is Bernoulli's principle. This is also going to be related to what you studied over here: low pressure, high pressure, and high velocity or low velocity. Now what is Bernoulli's principle? Now before looking at this picture, if you just make simple drawing, right? So let's suppose this is one area, and we are doing this. We reduce the area and it's going the same, right? Now considering this as A1, same with this A2, area 1A, and this is the area 1. Sorry, this is also area 1. Now this section, we call it area 2. This is the wind coming on, air molecule. We call it velocity of the air 1. Now when this area reduced down and the air molecules are coming along, now they don't have any choice, but they'll have to bend. And when they bend, it's going to create a very congestion over here. In order to resolve with this, what they'll do is they'll start accelerating, that I want to go first, I want to go first, I want to go first. Now in that process, what we get is a V2, right? V2. Now this area and this area is similar, but if you see this area, it's different. This is what we take advantage of, and this is the area. If you see closely, this area is what aerofoil is. You see the resemblance. Now if you enlarge this and just curve it a bit, it's the same, and that's what we do. Now what Bernoulli's principle state is that whatever the airflow that is coming along, it's going to accelerate. Now there's one molecule, I think I have made this drawing, convergence. Now there's one molecule, two molecules, one here, one here. Now one gets diverted upwards and one gets diverted downwards. Now the thing is that the A molecule will have this much of space that they need to cover, that is 20, let's suppose 20 meter, and B molecule will have only this much of space to cover, that is 10 meter for this example. Now they have this tendency, air molecule, of sticking together or being together. Now if they want to be together, the air molecule A will have to travel more because it's 20 meter, and air molecule B will have to travel just 10 meter. So the air molecule at A will try to go as fast as it can so that it can match the pace of B, so that they can meet together at point C. Hence, the acceleration that goes above the aircraft of the wing creates what? As we studied, high velocity. As you can see, the blue line is more area than the yellow line. Now, Bernoulli's principle is basically principle extent that fluid speed increases. As we discussed, fluid is what in this case? Air. Fluid is what? Air. Speed increases as the pressure decreases. Pressure, as we studied, it goes down and it starts accelerating. The key concept is to keep understanding lift the airplane and how airflow works. It's basically nothing but what they're stating is, as we discussed, the two molecules that are coming along got separated, one above, one down. They need to meet at one equal point. So the point A molecule will have to travel faster than point B, hence creating more speed or more velocity, whatever is better for your understanding. If you want to go for the technical term, you can see P1 energy half often side is so see, as we discussed, A1 A2 V1 E2 P2 P1.